Welcome to this explainer on the quantum frontier. Today, we're diving straight into the extremely cold cryogenic chambers and high-tech laboratories housing what absolutely promises to be a completely new era of processing power. But, before we get completely lost in all the hype, we really have to start by directly asking this massive question. Could quantum computers change everything? It's a pretty bold claim. And to actually answer it, we need to separate the science fiction from the actual science. Now, because quantum mechanics can cause some serious cognitive overload, here is our roadmap to break it down. We're going to start with a welcome to the quantum frontier, look at how they work, discuss solving the unsolvable, do a quick reality check, and finally look at our quantum future. Let's dive right in.
Okay, Section 1, welcome to the quantum frontier. Moving right along to Section 2, how quantum computers work.
Let's compare the old and the new. A classical bit, which is literally the foundation of all traditional computing, is strictly binary. It's limited to being just a 0 or a 1. But a quantum bit, or qubit, utilizes branching pathways. It actually exists in multiple states simultaneously. It's kind of like a spinning coin that is both heads and tails at the exact same time, right up until it's forced to land. And this overlapping state is exactly where quantum processing gains its incredible edge.
And that brings us to quantum entanglement. This is a state where multiple qubits become intrinsically connected, allowing data to flow instantly between linked particles. In practice, when you change the state of one qubit, it instantly affects its entangled partner, regardless of physical distance. It's wild. This allows quantum systems to process vast amounts of information in ways our traditional computers simply cannot.
All right, Section 3, solving the unsolvable. So, while traditional supercomputers really struggle to handle complex molecular simulations, quantum computers possess an unbelievable advantage in speed for these very specific, highly specialized tasks. Now, actually, it's important to note this doesn't imply universal superiority. Your standard laptop is still far better for writing a document or, checking your email. But for incredibly dense scientific problems, the sheer speed is truly unprecedented. This raw speed is already opening up some breathtaking possibilities across a variety of vital fields. We're talking about revolutionizing drug discovery by simulating molecular interactions in literal seconds. We're looking at vastly improved climate modeling, huge breakthroughs in material science, and even financial optimization to balance complex global markets. For researchers, this is a fundamental paradigm shift.
Which brings us to Section 4, the reality check.
We really have to step back from the hype for a second. While we're aiming for incredible benefits like scientific breakthroughs and advanced simulations, researchers are currently battling some massive hurdles. Error correction is a monumental challenge because qubits are notoriously fragile and prone to interference. Then you have extreme cooling requirements. These processors must be housed in cryogenic chambers colder than deep space just to remain stable. Because of these engineering hurdles, practical applications today remain pretty limited. Finally, let's look at Section 5, our quantum future.
The ultimate takeaway from this explainer is perfectly summarized by this thought. Quantum computing won't replace every computer, but it could transform humanity's hardest problems. Remember, these are highly specialized tools. You definitely won't have a quantum phone in your pocket anytime soon, but a quantum computer might just design the revolutionary, everlasting battery that powers it.
So, we have this emerging, immensely powerful tool at our disposal. The question is, which of humanity's hardest problems should we solve first? Should we cure a disease, stabilize our climate, or maybe invent materials we haven't even dreamed of yet? I'm going to leave you to think about that one. Thank you so much for exploring the quantum frontier with me today.